It is time for another high voltage eBay device. It's got so many nice high voltage things. This one came from a UK supplier that specialises in sauna supplies, and it's a company, Vapor. I don't know if that's that's what their listing is called. And it says circular ozone emitter sterilisation generator device for steam shower steam. Cost £26.74 plus £2.95 shipping. And it looks a bit like a ceiling speaker. It may well be based in the case of a ceiling speaker. And I'm guessing that the way this is designed to be mounted is that these were covered in hot melt glue when it arrived. Well, that's quite warm. It's running. Hold on, I shall hold it up so you can hear it running. So I'll find which way that little ozone plate's going. Can you hear it hissing? It makes a distinct hissing noise in operation. But this was covered in glue. 1, 2, 3, 4. I'm guessing it mentions self-tappers. I'm guessing that this is designed to be mounted from the back with screws going into it from the back because there's nothing really to mount it in the front. So I guess it goes into a sort of an electrical enclosure, which gives it its 12 volts, AC or DC. I've checked that out. It is AC or DC. And it says 100 milliamps. It's currently running at 12 volts DC at 200 milliamps, so perhaps not that accurate there. When you open it up, inside is, I'll zoom down for this. Zoom in. Oh, I tell you what, this little ceramic plate here works at quite high voltage, said Clive poking it. And these things do not like high voltage. These calipers, if I hold it in the vicinity of that, it just goes absolutely berserk. Now, for those of you who said that these are absolute devices, so let's zero it out and let's bring it back to a known position, say, I'll just zoom out a wee bit for this, 40.9. If I bring it near that, it's really messing with encoder, so it's not a relative position at all, it is a phase quadrature type encoder. That's interesting to know. And that makes me wonder if some of the people saying they weren't getting good battery life, maybe they were putting it near a power supply or cabling and it was picking it up and it was getting upset. But anyway, I've digressed already. Inside is a little ceramic plate, and if I touch the front of that plate, I may be able to draw a little spark onto my finger because it is high voltage. Yeah, it's made my finger smell of burnt pork. It's definitely been drawing a little tiny arc. And that is the ozone generator. I shall show you that in a moment. Underneath that, I could just turn this off. It is generating shit tons of ozone. Actually, I'll leave it on. Underneath this is the high voltage circuitry with, pokes metal screwdriver in, a high voltage transformer, and the rest is all potted under resin, but I kind of know what's under there, and I can actually show you that because it's almost certainly a Royer oscillator. So I'm going to turn the light off momentarily. So let's take the exposure off and see if I can show you this. I shall focus, I'll bring this up in fact, and I shall focus on that, and then I shall turn this off. Oh yes, you're seeing it. And we'll zoom down on that. That's the corona discharge generating the ozone. It's just like a little, basically just like millions of tiny little sparks creating a sort of purple glow. Very neat. Watch your eyes, the light is about to come back. In fact, you know what? I shall just pause for that. So watch your eyes, it's about to get bright again. Bright again and quite electronic-y too. Do you know, while I was doing this, I thought I could do with drawing these in purple, and I got one of the original pens that I've not refilled with black ink. Oh, hold on, I'll just lock the exposure, will I? Yo-yo exposure. And I've realised, I didn't realise it quite so much before. I don't know if you can see this. The length of the tips in the pens, they gradually wear down over time, and that affects the sort of line width. I think I need a new pen. This one is gradually wearing down. It must just, I don't think it's pushing in. I think the fibres physically wear off as I draw. So let's go over the circuitry. It's a standard Royer oscillator, a very common type of oscillator. I could have written that at the top. Royer. Look it up. On Wikipedia, it's got an article about it. It's quite interesting. And they're very, very common. A good example of those is in the cold cathode drivers for the little glowing tubes that they used to put in PC cases. They're about 1 foot, 300 millimeter long, and they were glowed really, really bright colours. But they operated about 1,000 volts, and that's what the circuitry is in them. It's basically, the nice thing about the Royer transformer is it's got two transistors and it does a push-pull. When one's high, the other's low. It basically, the output, instead of just being pulsed in one polarity, is going positive, negative, and that's needed in this application because it does rely on capacitive coupling. So the transformer has three windings. It's got the primary winding, the secondary winding, and a feedback winding. I've coloured them all orange to show that these windings are all connected. They're actually that thing in there. You can actually see the segmented bobbin there. Hold on, I'm just going to shine a bit of extra light in it. Shine a bit of light on my life, as they say. There is the sections of the bobbin. I'll explain that after. I'll explain it now. It's about 3000 volts. So the circuitry in a Royer oscillator has the 12 volt supply, goes to the middle of the primary via an inductor. In the case of this little unit, it is this little inductor here. There is a capacitor across the primary. That's this little thing in this one here, which is 40... Oh no, hold on, let me just check that. That's me going by memory. 68 nanofarad. Then the two ends of the transformer are alternately, the primary, are pulled down to the negative via these transistors. The two transistors in this are HE8050Ds, which are standard NPN transistors but optimized for amplifier applications. They're just a good characteristic. They're rated about 25 volts and they're capable of switching about 1.5 amps and dissipating 1 watt, though they did get pretty hot if you're doing that. The positive also goes to the base of each transistor via a resistor. Sometimes, as in the case of this one, there is just one resistor. That seems quite common. It's just a sort of way of saving money. It just provides a reference to the negative rail, effectively, for driving the base of the transistors. That will also be used to bias it on to actually start it up. So this transistor here will be the first one to actually power up, and when it does, it will turn on this primary winding. And as it does so, it will effectively, via this winding, it will actually drive this transistor off. And once that's fully saturated with as much magnetic field as it can move in, it can't continue to pass current, couple current through magnetically. So then it collapses. And now this one's turned off and this one's turned on. So it just creates that oscillation of these two transistors alternating backwards and forwards with that little feedback winding. The power is coupled over through a transformer to the secondary. Now, normally, if that was doing a cold cathode tube, you'd have a little capacitor in series to limit how much current can flow in each half cycle. Something worth mentioning. Neon sign transformers, you can actually run several tubes, electronic ones, at lower current by putting high voltage capacitors in series with each tube to actually ration the amount of current through it. It's a common trick used in some signage. But in this instance, it's covered across to this high voltage secondary, and because it is high voltage, it's wound as a series of windings on one bobbin with separators between them, just to stop it flashing over. If you just wound it all on top, it would potentially flash over inside the transformer. Again, that's a common way of making these high voltage transformers. And each end of the transformer then goes to a ceramic plate. The ceramic plate has printed conductive ink on each side. I can show you that. Hold on. Here's a ceramic plate with a printed conductive layer of metal on one side. I'm not sure how they do that. Whatever it is, they can actually solder onto it. So it may just be and it looks quite thick. So it is possibly deposited on as maybe powder and then heated to fuse it on or something, not really sure. But they have a solid layer underneath, and then they have the electrode pattern on the top, and that forms kind of a capacitor. But because some of the current will be flowing backwards and forwards just between the two electrodes through the ceramic, because this is how a ceramic capacitor is made, that's just made me realise you could almost use a little ceramic capacitor as an ozone plate. That'd be interesting to experiment with if you dissolved the resin off it. But where that electrode isn't actually covering, you tend to get a fringe around the outside. So if we take a look at this drawing down here, on one side we've got the main electrode, which doesn't emit any ozone at all, and it's got a central solder connection. On the other side, we've got the little central electrode, and sometimes that's one finger, sometimes it's two, sometimes it's a sort of figure eight. It depends how much area they want to actually create the corona discharge. But because Although some of the current is coupling through directly between this electrode and this one just capacitively, you also get a fringe around the edge where it's also, the voltage is high enough that it's trying to couple capacitively through the air. But because there's no direct route and it can't spark across, it instead forms lots of little tendrils and sort of fizzing corona round the outside. And that's what creates the ozone. Now, those of you who are regulars to the channel will know I'm quite intrigued by ozone. For those of you who are inevitably going to leave in the comments that it causes cancer and you mustn't breathe in any level at all, it does occur naturally in nature. In the Amazon rainforest, the droplets falling from the trees above will effectively have an effect in creating trace levels of ozone. And it is, in my mind, it is an essential part of the air to actually control bacteria, viruses, and spores and things like that. Any contaminants in the air, it limits the spread of them. Otherwise, they could just basically take over. But the way this works is as oxygen passes through, oxygen is O2, which is two atoms of oxygen bonded together. When it passes through, it can split them apart with the corona discharge, and they can sometimes combine again as an unstable O3, which is ozone. I'm guessing they'll also combine with other things. One of the things they say is nitrous oxide and things like that, nitric oxide. And also, I guess, OH, which would be an hydroxyl radical. But they combine momentarily, most commonly as O3, which is ozone, and it's not stable. It wants to get back to O2 and it wants to get rid of that atom of oxygen, so it puts it onto things like viruses. Hold on, I'll do a plasma cluster advert. So here's the virus, right, with all the wee things coming out, right? Okay, here's your scaremongering adverts from all the advertisers. This is going to kill you, and it's got a wee sad face and big eyes in it just to make it look deadly. And then the oxygen attaches onto it, the O1 effectively, and it oxidizes it, and then it's dead. There you go. That's the same level of advertising as those dipsticks use. Yes, the scaremongers. But if you can smell ozone like I can at the moment, that is actually too much. It is a strong oxidizer, and the room is stinking because I had this running for a while before making this video. The ideal level is a level about 0.04 parts per million, something that you can't even smell. That's about the right level. But this made me think of the people who work in swimming pools. They are breathing in chlorine all the time, chlorine-y bleach. That can't be good because you can always smell that chlorine when you go into the pool, and it always smells fresh, just like ozone. I wonder if that poses a risk to their health as well. But that's fundamentally what's in here. This is a dedicated, this is a little standalone one. This produces a lot more. This one makes the room really ming of ozone, which isn't great. Now, something you guys may be to answer. I might be about to answer this myself. Some of these, like this one, are just the bare ceramic with the little electrode, the ozone electrode. It's got the large one in the back. It's got a little finger in the front. Can this be pulled out? Is this actually glued in? Am I about to break this? It's crackly. So yeah, let's not. That is kind of glued in. That is going to break if I try taking it out. But some of them are just bare, but others have this blue coating. I wonder if that's Teflon, because Teflon, I think, is resistant to ozone. And that might just prolong the life a little bit by actually stopping attacking the metal, because the corona discharge itself, apart from the fact ozone is quite corrosive, the corona discharge itself acts like that electric arc machining, you know, the electric discharge machining, is it, where they actually cut metal out with a spark? So I wonder if that's to limit that by creating a barrier between the corona discharge and the metal electrodes. I don't really know. It's left a sort of stylish skid mark around it, a little sooty skid mark. I guess it's degraded the surface. I did try experimenting when I was younger. I got a thin piece of circuit board material, etched it with a couple of layers that didn't overlap on one side and the other. And then I connected high voltage across it, and I managed to get a nice corona discharge along the edge, and it was stinking. So I put it out in the close in Glasgow, and then opened the door later on to see how it was doing, and it was burning its way through the fiberglass. It had actually eaten all the resin away, and the corona discharge and arcing had actually exposed all the glass strands. Quite interesting, actually. It was stinking. Yes, it went from ozone to burning printed circuit board resin. Another thing that's worth mentioning about the electric sparks causing damage. Motors, if you run a motor on a variable frequency drive, you know the ones you can always hear the motors going wee in the background when they're running. You get it a lot in the fairground rides and the theme park rides. If you turn it up too high, on some motors, it can actually capacitively couple from the rotor of the motor onto the from the windings onto the rotor. And then it wants to find a path back to ground. So it actually goes to the case via the bearings. And that invisible arcing inside just gradually eats away at the bearings. And as they get worse, as they get rougher and pitted, it has a more of an effect. So they do ceramic bearings for some motors that are prone to that, non-conducting bearings. But there we go. It's an interesting device. It was worth getting, worth taking to bits. And I'll just add it to my big pile of things that produce ozone. Very odd that it's just all just glued together like that. It seems a bit amateur, but I guess that's just the way it is made. I thought this box was separate at first, but it is just moulded in. And they've sat the circuit board down into the resin and or poured the resin over it afterwards. And that's also sealed the cable, I'm guessing actually. They would have poured the resin afterwards, probably because some of it's on top, and also they've got the cable coming through the side that is then potted down into that as well. And the only way to get in that would be to basically thread the cable through from the inside, pull it through, put the module in, sit this into place, and then pour the resin all over this. But there we go, sauna deodorizer and mould preventer. I wonder what this bit's for. It looks as though it may have been designed to take some sort of tube, maybe the older style of gas discharge tube, either UVC or the glass discharge tube with the mesh around the outside, or maybe even just a piece of glass tube with a central core and an outer mesh as well. But they've gone to the ceramic because they're quite popular these days. But there we go. Interesting stuff. It was well worth exploring, well worth taking to bits. And if you ever see one, you smell that fresh bleachy smell in a sauna cubicle, well, that might not be a speaker in the wall. It might actually be an ozone generator.